Hello. Please hit like button and subscribe my channel. Also press bell icon for future video notifications. Thanks.
Researchers from the University of Southampton and Université Laval, Canada, have successfully measured for the first time back reflection in cutting-edge hollow core fibers that is around 10,000 times lower than conventional optical fibers. This discovery, published this week in the Optical Society's flagship Optica journal, highlights yet another optical property in which hollow core fibers are capable of outperforming standard optical fibers. Research into improved optical fibers is key to enable progress in numerous photonic applications. Most notably, these would improve Internet performance that heavily relies on optical fibers for data transmission, where current technology is starting to reach its limits. A small portion of the light that is launched into an optical fiber is reflected backwards as it propagates, in a process known as backscattering. This backscattering is often highly undesirable as it causes attenuation of signals propagating down the optical fiber and limits the performance of many fiber-based devices, such as fiber optic gyroscopes that navigate airliners, submarines and spacecrafts. However, the ability to reliably and accurately measure backscattering can be beneficial in other instances, such as the characterization of installed fiber cables where the backscatter is used to monitor the condition of a cable and identify the location of any breaks along its length. The latest generation of hollow-core nested antiresonant nodeless fibers (NANFs), which have been pioneered in the Southampton lead lightpipe research program and applied to novel application fields within the AirGuide photonics program, exhibit backscattering that is so low that up until this. To resolve this challenge, researchers within the University of Southampton's Optoelectronics Research Centre teamed up with colleagues from the Centre for Optics, Photonics and Lasers at Université, Laval, Quebec, who specialize in research into highly sensitive optical instrumentation. They developed an instrument that enabled the team to reliably measure the extremely weak signals backscattered in the latest fabricated hollow core fibers, confirming that scattering is over 4 orders of magnitude lower than in standard fibers, in line with theoretical expectations. Professor Raden Slavik, head of the ORC's Coherent Optical Signals Group, says, "I am very fortunate to work in the ORC, where the long-term, world-leading research of my design and fabrication colleagues has led to the lowest loss and longest-length hollow core fibers ever made. My work has focused on measuring the unique properties of these fibers, which is often challenging and requires collaborations with world-leading groups in measurement, such as the UK's National Physical Laboratory and Instrumentation, such as Université Laval, Dr. Eric Numcom-Fokua, who carried. Moreover, the ability to measure such low backscattered signal levels is also critical in the development of hollow core fiber technology itself, in providing a critical route to distributed fault finding in fabricated hollow core fibers and cables as needed to drive forward improvements in their existing technology is simply not sensitive enough to work with these radical new fibers, and this work demonstrates a solution to this problem. Story source: materials provided by University of Southampton. Note: content may be edited for style and length. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.